Okay, so today we're going to do three equations, three variables. There's a couple differences when you switch from three equations, three variables, switch to three equations, three variables from the world of two equations, two variables, okay? One of them is we're no longer dealing with lines, okay? So let me show you this website I found. Name of this website is Geom Algorithms. Okay, it's a good website. They've got a lot of good stuff on there. But this is a picture of what we're dealing with. It's no longer two lines anymore. It's three planes. Okay? So by planes, we mean sheets. Right? Okay, so there's lots of different things that can occur. All right, let's all look up here. This is super important because I can't draw this for you. I've tried drawing this stuff in the past. I give up. Okay, you can copy the other stuff on that board later. But let's take a look at this. So there's kind of at least 5 scenarios that can happen if you have 3 planes in space. And I can actually think of other drawings, but no new situations, okay? So let's just kind of run through all these different possibilities. So in this first picture, you can see that we have 3 parallel planes, right? So plane A, plane B, plane C, they're all truly parallel to each other. So what does that mean? They never what? They never intersect. Right. So if the planes never intersect, then our goal to find a solution is going to fail. Like we're going to fail that test, that desire. We're not going to get it. There is no point of contact. And if the solution to a system is a point of contact, that will never happen in a system like this. Okay, so this happens when, in your system, all the coefficients are just linearly dependent. That just means like, this might be 3, 1, and 4, but then this is 9, 3, 3, and 12. In other words, it's just triple the coefficients from here. Okay? So like the coefficients A, B, C are just 1/3 of the coefficients D, E, and F or something. And so what that does, it makes the planes look parallel. Or maybe all 3 of them are the same coefficients, just like tripled or doubled or halved or something. Okay? So the other possibility is if you add A and D together, and you add B and E together, and you add C and F together, the outcome is like, let's say A and D, B and E and C and F adds up to 1, 2, 3. But then you look down here, G, H, and I are like 10, 20, 30. That's linear dependence. So you have like the coefficients or the sums of the coefficients come out to be like a multiple of the other coefficients in the problem. So this can happen. It's kind of rare, but we might have 3 planes actually that are completely parallel in space. And we would never expect to find a solution. Okay, the second picture is the one underneath it. You might say, well, these planes contact each other. Not really. The vertical plane, each vertical plane intersects the horizontal plane many times actually. But I can't see any places where all 3 planes join up. You know what I mean? Like if I put my finger where my arrowhead is pointing right now, technically 2 of the planes are touching on this crease right here, but I wouldn't say the 3rd plane is involved at all, unfortunately. So if our goal is to find a place where all 3 contact each other, that doesn't happen in this picture. Okay, let's go to the top middle now. Here all 3 planes touch, but they don't form a unique point. See the problem? Like, where do these 3 touch? Well, they touch anywhere along this line right here. That's not a point of contact. That is points of contact. That's kind of an infinitely many solutions sort of thing, if you get my drift. It's definitely an odd situation. The picture underneath that, you can see here, what's going on is the top 2 planes here intersect to form this line. And then the bottom down here, we've got like these planes touching to form this line right here. And then in the back, you can kind of see it there. There's 2 planes that contact to form a 3rd line. But what do you notice about all 3 lines? This one, and this one. What do you notice about those 3 lines in space? Right, they never touch. So you're never going to get a point of contact for these 3 planes. One way to see that is drawing those 3 red lines. See how they're parallel? Parallel lines don't touch. So if those don't touch, then the planes don't touch. So again, it's kind of a no solution sort of thing. This is the only of the 5 pictures. The one on the right stands alone and stands out from the others, because that one really does have a point of contact at the sort of like the origin of the picture. Okay? So my marker's not working too good here, but I'm not sure why I can't draw on there. But basically right here, you see, that point is the point of contact and is the solution to the system. So you can see that if I just gave you 3 random equations of 3 planes, like what are the chances that they all be parallel? Like, that'd be really, really unusual, right? Or that 2 of them are parallel even. What are the chances that they all intersect to form a straight line like that? That's crazy. Like, that's so rare, right? Most problems have a solution. Now, not always are the planes like perfectly perpendicular to each other, but you can imagine, like, maybe if this angle right here was like 89 degrees or 75 degrees, these could all sort of cross, even if I tilt the planes a little bit, right? So there are many other pictures we could draw, but they're just sort of modifications of these. Another possibility is if you go back to image 1, right over here, we could actually take the 2 planes that are in the front here and collapse them into one plane. Like imagine I took these front 2 planes and squished them together, so there's really only 2 planes in the problem, but you thought there were 3. That's actually another feasible situation, and that's true for any of the pictures you're looking at. So I could like collapse the planes together, and I could collapse all 3 together to form a single plane, and then you would be like, oh, this looks like a problem with 3 planes, but it's actually all the same plane, you didn't realize it. So there's other cases of infinite many solutions, there's other cases of no solutions, but these are sort of the top 5 pictures. So I really like this image. I can't draw it myself, but I have to show you. Okay? All right. So the equations look different, right? It's not just ax plus by equals e and cx plus dy equals f. Let's go back and write down what these would actually look like. Maybe you already wrote this. But basically, your equations are longer now. Your equations are ax plus by plus cz equals something. Let's say r. Okay? And then you have dx plus ey plus fz equals maybe s. And then you have gx plus hy plus iz equals t. And obviously this is not I like square root of -1. It's just trying to come up with letters for these numbers, you know. Okay, so the example I chose for this lesson is specifically this system here. So today's example is 2x minus 3y plus 4z is 8. X plus 3y minus 2z is -3. And lastly, 3x minus y plus z equals -1. Okay, so what are our graphing methods what are our methods that we've been using? The first one was the graphing method, right? Graphing method. Do you think a graphing method is a good method here? What do you guys think?
No.
It's probably not a very good idea to try and graph this. I'm actually going to graph it for you and show you what it looks like, but you'll never be able to guess the solution from looking at my ugly picture. Okay? But I think no one has ever shown you how to graph a plane, and that's really a bummer because you were supposed to learn it in geometry, but there's a lot of reasons, but a lot of political reasons why we had to stop teaching graphing of a plane. It's a real bummer that you didn't get to see it because it's really easy to do. So I'm going to show you how to graph a plane real quick, and you'll probably be like, oh, that's really easy. Okay, so what you do is you graph an x, y, z axis system. Okay, do you remember doing that? I'm going to draw that. And then you have, this is x. So I like to tick off the axes. The axes get really ticked off when I do this. Okay, and then this is your y-axis up here. I just went out to 8. And then the z-axis is vertical. And I usually tick my axes so it's parallel to the x-axis. I don't know why. Okay, so how do you begin graphing a plane? Well, there's a lot of ways to do it, but one way is like this. Watch close. You take your first equation, 2x minus 3y plus 4z equals 8, and you basically plug in 0 for both y and z. So I just plugged in 0 for y and z. I basically scribbled out y and z. So what does it look like? 2x, what? Equals 8. What's x? 4. So what this means is that when x is 4, both y and z are 0. Does that make sense? I covered up y and z, right? Meaning I'm making them 0. So 4, 0, 0 is definitely on the graph. Okay, 4, 0, 0. So I'm going to write that down. 4, 0, 0. Okay. Now I'm going to cross out the x's and the z's. What does this give me? Negative 3y equals 8. So what's y? Negative 8 thirds. Right. Okay. So when x and z are 0, y is negative 8 thirds. Okay, now I'm going to cross out x and y. What does it look like now? 4z equals 8. Z is 2, right? So when I covered up x and y, z was 2. Euclid said if you have 3 points on the plane, you have the plane. You got the plane. Okay? 2 points determine a line. 3 points determine a plane. So if I plot these 3, I can visualize the plane. I'm going to do my first plane in purple. Okay, so I need to plot the point 4, 0, 0. 0, negative 8 thirds, 0. That's like 2 1/3. So like right about here. And 0, 0, 2. Okay, so what you're looking at here is a triangle, of course. But it actually represents the whole plane. Okay? Because the triangle is the polygon with the least number of sides, right? So if you can sketch the polygon, you can visualize the plane. I can sort of see the plane here, although it's kind of hard to draw it. If I drew it, it looked like kind of a parallelogram on the page. So let's just pretend that's sort of our surface right there. Okay? Everybody got that? Was that hard to do? Not at all. Why didn't you learn it in geometry class? Time reasons. All about time reasons. Look how easy that was. 2 minutes to learn to graph a plane. All right, let's graph the other 2 planes. The goal is, of course, to see where they all cross, right? So let's see here. I'm debating whether I should shade this thing or not. I'll shade it. Okay, let's graph the next plane. So the next plane says x plus 3y minus 2z equals negative 3. If I let x and y and z be 0. I want to do a y and z, right? Okay, yeah, so x plus. Let's make y and z 0. I get negative 3 when y and z are 0. All right. Let's make x and z 0. Looks like y is negative 1. All right. Let's make x and y 0. No, z is 1.5. You know I like decimals with plotting, right? Okay. 0, 0, 1.5. All right, let's plot those guys. Let's do this plane in, what's a cool color? Puke green. Okay, puke green it is. Negative 3, 0, 0. I guess that's over here. Man, that's an ugly color. Okay. And then I have 0, 1, 0, negative 1, 0. So I guess that's over here. And then 0, 0, 1.5. All right, this is getting really hard to look at. You guys agree? All right. And the third plane, without showing a lot of work, the third plane passes through x equals 1/3. Negative 1/3 technically, so on this side. It passes through y equals 1, and it passes through z equals -1. So it too forms a little triangle. So man, this is so hard to visualize, but the idea is that all three of these represent planes, and somewhere in space they cross. So you can see the graphing method is horrible, but now you know how to graph a plane. It's actually pretty easy. Okay. So we won't do graphing method. And I don't know why, but when I was in high school, my favorite method was substitution, which is a horrible method for this. So I really struggled with these problems. But graphing method, kind of lame. Substitution method, it's not very good. Okay? You have to isolate y in two equations and substitute them in. Then you got to do it in the third equation. It's a mess. It's a real mess. Okay, so actually the first method people actually use is elimination. Okay? So let's try it real quick. So what I usually do is I'll pick two equations. So pick any pair of equations. So let's number these. Roman numeral number 1, Roman numeral number 2, Roman numeral number 3. Okay? Let's just pick equations 1 and 2. Say 1 and 2. Okay, so you put these two equations right next to each other, one on top of the other like this. You can kind of see that it's really easy to get rid of y. In fact, if you just add these equations together, you get 3x plus 2z equals 5. So we eliminated one variable. Now you don't have to eliminate y, it just seemed very convenient to me. You could have eliminated z, for example. Okay, then you pick a different pair of equations. So pick another pair. Let's say the first and the third one. First equation is third equation. So this is maybe 1 and 3. You could do 2 and 3 if you wanted. But here's the thing. Last time you eliminated y because it was convenient. Now you're kind of forced to eliminate y again. So you must eliminate the same variable as last time. So if on the first time you eliminated y, you have to kind of do that a second time. Or maybe on the first phase you eliminated x, then you should repeat that here, okay? All right, so I'm going to multiply the second equation by -3. That way this will work out well for me. I have 2x minus 9x. The y's are actually gone. And I have 4z minus z. And don't forget to do the right side. You're really doing 8 plus 3 here. Okay, so these two equations are very important. You found this equation and this equation. What you've effectively done is you've transformed this 3x3 problem into a 2x2 problem. So what you have now is literally 2 equations and 2 unknowns. That's good. You've reduced the system. Okay, so now we can solve the 2 yellow equations however you want. You can use any of the methods you learned in the last section, right? Okay. I'm just going to continue on with elimination because that's what I've been using. But here are your 2 equations. 3x plus 2z equals 5. Negative 7x plus z equals 11. And I think what I'll do is just multiply the second equation by -2 and add these together. So I end up with 17x, because I have 3x plus 14x. The z's are now gone. And I get basically 5 plus 22, which is 27.
So x, unfortunately, is 27/17. Let me double check my work here. Does anyone see an error? Negative 22 plus 5 is not 27. 5 minus 22 is negative 17. Yeah, I was getting a little worried, actually, because I already knew the answer was supposed to context was negative 1, and I was getting a little concerned that maybe I copied the problem wrong. That would be bad. Okay, as you know. Now that you have x, you can get y. Oh, let's make a note. What did we do? We solved the 2 by 2 system that we've created, right? We've used linear combination to create a little 2 by 2 system. So that's what we're going to write for our notes here. So basically C, yellow. Okay? Okay, once you have x, the problem's kind of in the bag. What you would do now is take your x and plug it into any equation anywhere. I suggest you use one of the yellow equations. So let's substitute x into one of the yellow equations. So substitute into any two-variable equation you've seen. There's equations everywhere, but have you seen any of the two variables? Yes, we have. We saw an equation right here, 3x plus 2z equals 5. Why not put in the negative 1? Okay, so basically, you end up with z equals 4, because you're going to end up with 2z is 8. So now you know z. And then the last thing you do is substitute both results into any of the three variable equations. Right? So you kind of go back to the original problem maybe and pick one of the original equations. This was the very first equation on the board. Right? But now you know x and z. X is negative 1. So x is negative 1. And z is 4. So you end up with negative 2 minus 3z plus 16 equals 8. Negative 3z equals negative 6. And finally z is 2. Oh, I meant to put a y in the middle, not a z, sorry. This is a y. Y is 2. Okay? Alright, so my answers in alphabetical order were negative 1, 2, and 4. Obviously, you want to put them in alphabetical order x, y, z, right? So what does this represent? This is the point in space where the three planes cross. And it's a unique point. There's no other point like it. Okay? It's a very special location. If you're standing at the point negative 1, 2, 4, these three planes slice right through that point. So watch out. Here they come. Okay? That's where they all meet. We're actually very familiar with this idea, like on this cardboard box, right? This point right here. This point right here is an example of this, because this plane, and this plane all meet right there. But that's a unique corner, right? So that's what it represents. You need to work out there. All right. I know it's weird to see a teacher in a green bow tie. You can thank my 7-year-old and 4-year-old for that. Okay. What about other methods? Like, are there faster methods? Well, one thing that we had to do a lot of in this problem is writing, right? Look at all the writing. X's here and there, and Y's and Z's and equal signs, plus all the notes we wrote. But we could actually do sort of a row reduction type method where you don't write all of your x's, y's, and z's, but rather just put the coefficients in. 2, -3, 4, dash line, 8, right? 1, 3, -2, -3, 3, -1, 1, -1, you see? You can see that this is just laziness, that's all it is. It's people being too lazy to write x, y, and z 3 times. Okay, what is our goal in row reduction? There are 2 goals in row reduction. 1, to get one number, 0, 1, number, 0, 0, 1, number. This is called a triangular system. And it's, the left side is considered, or actually the whole thing is considered REF, row echelon form. Okay? This is one goal. Some teachers say, this is our goal, class, let's get it to look like this. All right? The other way is to go a little further and get it into what's called RREF, reduced row echelon form. Or RREF, reduced row echelon form, looks like this. 1, 0, 0, x. 0, 1, 0, y. 0, 0, 1, z. This is the reduced version of REF. And it is more specific and better in a lot of ways, okay? First of all, if a student plays around with the matrix and can create REF, their REF might look different from their neighbor's REF. Okay, so for example, you might have 1, 2/3, 5 9s, 16, and the other person next to you has an REF, and theirs is like 1, 2, 4, 6. But they're both correct. Both students are correct. This is very annoying when you have 2 resulting systems and they look different, but they're really the same thing in disguise. That's just annoying to me. So being kind of an OCD person, I like RREF. It's a lot more work to get RREF, but if you get RREF, everybody's answer looks the same. The other advantage is X, Y, and Z, your 3 answers will be chilling right here on the right. They'll just be waiting for you to circle them. Okay? So it's kind of a toss-up philosophically. Like some teachers are like, let's just do REF. Once we get there, the problem is really easy to solve without matrices. My thing is, well, let's just get it all the way to RREF. You've already got halfway when you got to here. In blue, you might as well finish the problem. And then you'll get your answers for free in the end, even though you worked hard for it. It's also extremely rewarding to get to RREF. It's like solving a Rubik's Cube halfway versus solving Rubik's Cube all the way. Which one feels better? All the way, right? Oh, I got half the colors. That's an amazing achievement. Don't get me wrong. But you might as well go all the way, you know? Okay, speaking of Rubik's Cubes, I think I asked you guys already, how many of you guys know how to do a Rubik's Cube? Okay, so do you know the algorithms, or you just? Yeah. Okay, so correct me if I'm wrong, but isn't there something you can always do to get back to where you were before? Is it? Okay, so there's like a certain pattern, like twist this, twist that, flip it, do that, do this, that, did. And if you do that do thing with your hands, then you will be back where you were a minute ago. Is that right? Okay, that is very, very important, right? Because you might have all the reds figured out, but then you got to go on the back and do the whatevers. What's on the back? Green. Okay, you got to go do the green. You're going to have to mess up the reds to get the greens to work. And then you're going to have to figure out how to fix that. But Andrew hasn't memorized. He knows the strokes to get it back. You see? That's so important, right? Otherwise, people are just blindly trying to undo what they did before. They don't remember what they did or whatever. I might have it wrong on the Rubik's Cube, but I believe there are algorithms that will either return you back to where you were or advance you to the next level. Okay? So that's why people can do it with their eyes closed. It's not because they're looking at the colors, it's because they know the algorithms. Right? Okay, so they can do something with their eyes closed. So just remember that principle when you're doing RREF. You might feel like you're going backwards sometimes and losing ground. But as long as you sort of follow my pattern, I think you'll be fine. I think you'll be able to solve any problem, all the way to reduced row echelon. Okay, so we're going to go all the way to our REF, and when we hit REF, we'll make a note of it, but we'll keep moving. Okay? So let me show you what I do. You might want to write this down. There are many zeros that we wish to get. I always start here. Okay, so step 1 is to create a 0 in this spot. Step 2 is to create a 0 in this spot. Step 3 is to create a 0 in this spot. I'll label this step 2, step 3. And once you've got those 3, you're pretty much in REF form. Then you jump up here and you do this spot. Then you do the one underneath it. And then you do, lastly, the top middle. Now you have a little flexibility with this. You don't have to do the greens first and the purples. You can actually do the purples first and the greens. But the idea that you get a 0 and then you shoot for the 0 above it, that idea is important. Okay? And you save this loner guy for last. He doesn't have a partner above him. So you do that one third. And then you go up here and do the same thing. So you do top right, the one under it, and then the one next to the top right. Okay? This is exactly what I'm going to do. I'm going to do it on every problem every time we do this together. So I never change. I'm very routine. All right? So where's my first target spot? Lower left. So I'm shooting for this spot right here. Trying to make that a 0. How am I going to accomplish that? Watch close. If I want that to be a 0, it might be nice if the middle row had a -3 in it. So I'm going to multiply the middle row by -3. I'm not going to touch the top row. I'm not going to touch the bottom row. Just going to multiply the middle row by -3. It's now -3, -9, 6, 9. Okay, then I'm going to add these two rows together. Sum is a noun and a verb, right? I'm going to find the sum by finding this by summing, right? So I'm going to sum them. The arrow means I'm going to, the word here means I'm going to add them, right? And then the arrow means I'm going to place the sum on the bottom row. So when you add these two, you get literally 0, -10, 7, and 8. Those are going to replace my bottom numbers. Okay? So I'm not touching the top row. Not touching the middle row. Just trying to get that bottom left 0. So I have it now. It's basically 0, -10, 7, 8. Okay, I just accomplished my first of 6 goals. Next spot is right above it. I'm shooting for that now, yes. So I think what I'll do is multiply the top row by 3 and the middle row by 2. So now the top row reads 6, -9, 12, 24. And the middle row reads -6, -18, 12, 18, but I'm not touching the bottom row. Why did I do that? Because I planned on adding rows 1 and 2 together to create another 0. Okay, so I'm not touching the top row. Not touching the bottom row. I just wanted a 0 on the middle row there on the left. And I got it. Here it is. If I add those two together, I get 0, negative 27, 24, 42. Okay, if you see any mistakes, please tell me, because I'm definitely weak on the arithmetic, and if I make a mistake, it's going to mess us up big time. I'm serious. You have to tell me if you see a mistake, or it's going to mess us up with time management. So, alrighty, we got 2 of those. Where's my third target spot? Right where that negative 10 is, right? Let's get rid of that guy. Okay. So we're going to, let's see. I do not want to deal with row 1. Let me explain why. I'm planning to replace this bottom row. Okay, that's my goal. I want to replace the bottom row. But if I add it to the first row, I'm going to get a 6. And I don't want a 6 here. I want a 0 there. So I'm going to work with the middle row and the last row. I do not want to touch the top row right now. Adding rows 2 and 3 will preserve the zeros I have worked so hard to get. So I'm going to multiply the middle row by probably 10, bottom row by negative 27. So you can see the numbers are getting kind of big here. Sometimes they get big, sometimes they don't. I'm going to multiply this row by 10, multiply this row by negative 27. Okay, so 6, negative 9, 12, 24. That doesn't change. And then this middle row is 0, negative 270, 240, 420. The bottom row is 0, positive 270, 189, negative 189, because that's 49 plus 140. And then 27 times 8, 56, 216. Let me check. 27 times 8, 216. Yeah, 216. And it's negative. You guys are going to correct me if I make mistakes, right? Okay, then we're going to add these 2 rows together, obviously. And I get not changing the middle row. But I'm adding the 2, and I'm getting 0, 0, 240 minus 189, 51, yeah. And then 204. Okay, now the numbers sometimes creep up on you and they get bigger and bigger. But what you can do now is you can go back and divide things back down to size. For example, if you're getting annoyed at the large numbers, guys, watch close. If you're getting annoyed at the large numbers, you could technically multiply this top row by 1/3 right now. You can multiply this row by negative 1/10 or something. And then you could multiply this bottom row by 1/51. In other words, you could get this back down to like smaller numbers. So now it's not as intimidating. It's 2, negative 3, 4, 8, you see? And this row just reads 0, 27, negative 24, negative 42. And this bottom row is, look, 0, 0, 1, 4. You see? So just kind of get it back down to like smaller numbers again before you proceed. Okay, so we've reached the halfway point. This is a point at which a lot of teachers will just say, okay, let's stop this. This is a lot of work. And what they do is they look at the last line, and what it really reads is that 0x plus 0y plus 1z is 4. This last line is really just telling us that z is 4. You see? If you interpret what this means, no x's, no y's, and 1z all add up to 4. That means z must be 4. So what you've reached here is the triangular system case. This is the triangular system. And it is actually pretty easy now to just stop using matrices and go back and solve the problem. You actually know z is 4 right now. Okay? If you want to, you can multiply this row by 1/2 and this row by 1/27, and that will get you an REF form. But I told you that I was planning to proceed all the way to reduced REF, so we're going to continue on. My next goal is, as you know, right here. So I'm going to multiply the top row by 6. And I have 12, negative 18, 24, 48, 0, 27, negative 24, negative 42, and 0, 0, 1, 4. And I'll be adding rows 1 and 2. This time I'm going to put my answer along the top. Remember my target was to get that 0 on the top row? So adding those, I get 12, 9, 0, 90. No, what am I saying? 6. Next time I'm going to learn how to add 48 and negative 42. 6. Okay, next target is this spot. So I'm going to multiply the bottom row by 24. That seems kind of counterproductive. Our bottom row is so beautiful, but we kind of need to do that. So the top row is 12,906. Middle row is 0, 27, negative 24, negative 42. The bottom row is 0, 0, 24, 96. Then I'll add these two together, placing the answer along the middle row. Top row hasn't changed. Here's a new middle row for you. Ooh, I gotta be careful. Yeah, that's right. 0, 27, 0, and 54. Bottom row is 0, 0, 24, 96. And one more target spot right where that 9 is. So I'm going to multiply the top row by negative 3. Negative 36, negative 27, 0, negative 18. Zero 27, 0, 54, and 0, 0, 24, 96. And then I'll sum these two together, placing the answer across the top. Here it is. Negative 36, 0, 0, and 36. Middle row, 0, 27, 0, 54. Last row, 0, 0, 24, 96. And if I multiply the first row by negative 136th, the second row by 127th, and the last row by 124th, I get reduced REF. 1, 0, 0, negative 2, negative 1, excuse me. 0, 1, 0, 2, 0, 0, 1, 4. And that's just satisfying. Negative 1, 2, 4. How much paper did you use?
Page.
2/3 of a sheet.
2/3 of a sheet. Oh, landscape. That was smart. Yeah, that's actually smart. I didn't think of that. Yeah, this is why when I was in college, I stopped using lined paper. It's like, I just stopped using lined paper. I thought I could write a lot smaller, you know, like Cecilia used to do. You don't write as small as you used to. Did you used to write pretty small? Yeah, it's still pretty small. Yeah. It's neat though. It's all tidy, right? But yeah, I remember my professors would write small on the board. I was like, I couldn't even see it. So I actually did not even see this until second year of college. But it's not that hard. It's just a lot of work. And it is hard. You know what's frustrating about it is when you first do it, your first time on your own, you find yourself losing zeros that you had worked so hard to achieve. That's why I came up with a method to show you, like,
what exactly to do in which order. That way you're much less likely to go backwards. But if you do find yourself going backwards, don't erase, just keep going forwards if you can. Let's say you accidentally get a 0 in sort of the wrong space. You can swap your rows around if you want. So you can actually take, let's say you ended up with, I'll just show you what I mean. Okay, so is that our last method? No. That was the first of the 3 matrix methods, right? So let's talk about Cramer's rule for a minute. So Cramer said that x is d sub x over d, y is d sub y over d, and z is d sub z over d. And you remember what these mean, right? So they're just determinants is what they are. D is just the original problem's coefficients. So it's just this stuff. That's D. It's just the original coefficient matrix. D sub x has the first column replaced with the 8, the -3, and the -1. You see? So the top and bottom actually look identical except for the first column here. And if you work this out, you literally get, I think it's 17 over -17, which is -1. Are you guys good with determinants? 3x3 determinants now? Well, if not, you can watch the rest of this video. I was going to record the rest of it later today. And then I'll just finish this example. As for inverse method, there's no way you would do that on the first day. So I'll send you a worksheet where you have to do a row reduction and a Cramer's rule only tonight. We're not going to use elimination. Okay, see you guys. Bye.
All right, so when you solve the okay, so it's been a while since we've done the 3x3 determinant case. So we did this with vectors. If you remember, we crossed product 2 vectors, and we did this sort of by taking the top row as a starting point, and I'll do that again. I kind of use the same exact method each time. So I'm going to start in the upper left and write down that 8. So I'm going to write down that 8 right here. And I'm going to do a minor determinant using these 4 numbers. So right here, let me show you. So I'm going to use these 4 for my determinant. So it's going to be basically 3 minus 2. 3 minus 2. Okay? And that will go in here, 3 minus 2. Then there's a mandatory subtraction. It's really easy to forget. But now we're moving on to this term. Right here. -3. Okay? So let's write that down. And for our determinant, we'll be using these guys here. So it's basically -3 minus 2. So basically -5. So -3 minus 2. Then we go back to addition. And now we're on this term. That's the 4. And we'll be using for our determinant these guys. So basically -3, or sorry, +3, take away -3. So 3 minus -3 is basically 6. Alright? Alright, so that's kind of how you do the top and the bottom both actually. So the bottom would be just different numbers, but it's 2 times 3 minus 2 minus, and then it's -3 times 1 minus -6, so 1 plus 6, back to plus, and then 4 times and then negative 1 minus 9. Okay, so the top is 8 times 1 plus 3 times negative 5 plus 4 times 6. The bottom is 2 times 1 plus 3 times 7. And then plus 4 times negative 10. Okay, so the numerator is 8 minus, basically 8 plus 24 is 32. 32 minus 15. The top is 17. The bottom is 2 plus 21 is 23. 23 minus 40 is negative 17. Okay, so negative 17. And the bottom and the top are the same except opposite. So you just basically get negative 1. And this jives with the other answer. It's important you recognize that this negative 17 is also the same as the denominator of the next two, right? So you already know now that this is negative 17 for the next two problems. So that's nice. Okay, so it's kind of a lot of work to do a 3 by 3 determinant, but it does work out. And let's go on and look at the y and the z version of it. Okay, so the numerator, we'll go a lot faster this time. The numerator is set up differently. This time, our first column is 2, 1, 3. The middle column is the 8, negative 3, negative 1. And the right column is the 4, negative 2, 1 as before. I'm going to erase some of my work up here just so I have more space. I'll just keep my results here, like that. Alrighty. Okay, so for my numerator, I have 2 times negative 3 take away 2. So negative 3 take away 2 is negative 5, right? So negative 5. And then minus. And then I have an 8. And it's 1 minus negative 6, so it's basically 7. And then it goes back to plus. And we would use the 4. And the 4 numbers in the left corner. So basically these ones I'll circle them in blue. We'll use those guys. So negative 1, take away negative 9. So it's basically 8. Just be careful with your double negatives and stuff. But you have negative 10. Here you have negative 10. And here you have a negative, basically I have negative 10, you have a negative 56, that's negative 66, you're adding 32. This is negative 34 on top. You already worked hard to get the denominator, it was a negative 17. Sorry about the copy error there, it's a negative 17. So this just comes out to 2, as we saw before. Okay, so determinants don't have to take a lot of space, just only if you're not real good at them. Okay, and the next one, we put the 8, negative 3, negative 1 into the last column. Alright, so we end up with 2 times negative 3 minus 3, so this is just a negative 6. And we have a mandatory subtraction, we have a negative 3 here, and we have negative 1 minus negative 9, so negative 1 plus 8 plus 9, that's a positive 8. And then a plus, and we have 8 times negative 1 minus 9, so negative 10. So we have negative 12 plus 24 minus 80 over negative 17. This is 24 minus 92, which is negative 78 on top. And you're dividing by negative 17. So this comes out to exactly, hold on, that's not right, 68. Negative 68 on top. This comes out to exactly 4. So again, we see their answer is negative 1, 2, 4, using Cramer's rule as well. Now there's a 3 by 3 determinant method, or excuse me, inverse method, but I was going to put that in the next lesson. So, alright, you have a worksheet that's posted for you. So go ahead and download that and start on that.